Alright guys, in this video today we're going to do some learning of HashMaps and a specific utility map I created. It's actually two kinds, a SetPairMap and a PairMap. PairMaps are like HashMaps, but they have reverse lookup like, I'll explain in a second. So a regular HashMap requires a few things. First of all, you have to type in HashMap, because that's that class type. So we have HashMap, and we have our two type parameters. And for the first one, we're going to have integer, and then for the other one, we're just going to have string. And we're going to call it a regular map, and then HashMap integer string again to initialize. You have to have these both be the same because that's the type of object it is. If you don't have these type parameters the same, it will not think it's that same object type. Alright, so they're matching, and that's this. So we can easily just do system.out.println hashmap. Wait, no, regular map, sorry. So we can print our object to string, I believe. Alright, and it has empty braces because we don't have anything in it. So here we can do regular map dot put 0 and sum. Okay, let's run that and see what it does. Alright, so it says that the key 0 equals sum, the value sum. Alright, so we're storing sum at 0. Let's try this. What happens if we put in something else like sum1? It overrides it and puts sum1. So 0 equals sum1 instead of sum, and sum1 overrides it. We can look over this, and it says associates the specified value with the specified key in this map. If the map previously contained a mapping for the key, the old value is replaced. And that's basically how these work. But what you can't do is you can't reverse it. You can't say what keys are tied to this value. For instance, if I say regular map dot put 1, and then I put sum, and I print that out after getting rid of this line because that was just an example. So 0 stores sum and 1 stores sum. It says it 0 equals sum and 1 equals sum, and that's totally possible. We're just storing these values at these keys. It doesn't care if they're the same value at separate keys. It's just that one key can't hold multiple values. Now that value can be saved elsewhere at that key, and that doesn't matter. So that's interesting. So we can't put more than one value at one key, and we can also have the same value at any keys we want to. Fine, cool. What else can we do? Well, we can do regular map dot key set, and it'll print out the key set, which is 0 and 1, and it just basically spits out the keys in the map. Or you say dot values, and the only values in here are sum, although it's in there twice and I don't know why. Okay. Interesting. That is not supposed to happen. Returns a collection. Oh. Okay. Let's see what this does. Alright, so it's holding two strings in there. That's interesting. I didn't know it would do that. Okay. So that's for the regular map. Now let's visualize that for a second. 0, sum, 1, emos. Cool. If we put in emos here, it would say emos. If we wanted it to. That's fine. That's just for the example. Alright, so green is the key, blue is the value. Alright. Well, what do my maps do? What does my PairMap do, and what does my SetPairMap do? And we can easily figure that out. We do pair int 0 and some, I think. Uppercase, right. Set pair, or set int to string. Actually, no. Pair int to string. Okay, you're going to see something here. And you're going to see that my toString is very intricate and for debugging, and you can tell what's in it. So we're going to try that. Alright. So here we have pair keys. So that's the regular key and value, the same way we see it here, except it's showing a specific object in here and what its toString looks like, which is okay. What HashMaps do is when they call their toString method, which spits out the data it shows when it's calling that method, HashMaps, whenever they say toString, they get all their keys and values and say toString on them all. And that's fine. That's what I want it to do. So at 0, we hold a single pair, and it's a 0, and then some, and then it has value, and that's where the true comes in. And then it also tells us 1 equals, and then it's emos and true. This is just the pair object. Okay, and then here, well, it's just showing all of it. Okay, and then the value keys. Sum is set at 0, or is being used at 0, and emos is being used at 1. So let's try something here. Let's see what, if we set them both to the same one, if they both are saving the value sum. Here, we try this. We notice something. Before it said sum equals, and then it held 0, and then emos held 1. But in this case, they both hold sum. They're both holding sum. And that's interesting, because here, with the pair map, I can check, is this value being held at other keys in a split second? I don't have to iterate through anything. It knows it or not using the inner hash maps that I have that object holding. And here I can say dot get values, alright, and see what it says. The values are sum. Although before it showed 2 values, here it's just showing 1, because all I need to know is whether or not that value's there. That's all I need. And it's a set, so it's only going to show 1 of each. It's not going to show both twice. Before it was a collection. Alright, so here we can do dot get keys of, and then we say, okay, what are the keys held on sum? What keys are holding the value string sum? And we try this. Alright, 0 and 1. That is very specific, and I can maximize my CPU efficiency very well using this. So now that we have that, we can also do dot actually, no, that's all we really need. Alright, so that's what that does. Let's try set int to string. Let's see what this does, because that was just for one value holding, or one variable storing another variable at that variable. That's all that was. It's just 1 for 1. But maybe you want to hold 1 for many, or many for 1, right? So here we're just going to store a key, and we're going to be able to store multiple values, but not at once. My apologies. Okay, so here we're going to do, set int to string, and then set int to string. Alright. So let's try this. Let's put emos. Okay. Cool, so this one looks a little bit more complicated, and it kind of is. Here we see that sum equals 0, emos is at 0, and then at 0, we're holding sum and emos, because that's a set. So we're able to hold multiple values at one key. It took me a while to come up with this, but I figured out how to do this, and it works flawlessly so far. I also have the value keys, so when we reverse this, we want to know what is sum attached to and what is emos attached to. So let's complicate this a lot. Let's just copy and paste. So let's say we want 0, 0, and then 1, 1. And let's put 1 in front of this, and then 0 in front of this. And then here we can do another one and call it, and put 0 there. And we're going to comment this out because we'll use it later. Alright, let's see what this does. Okay, so here we have pair keys, 0 holds, 0 sum, and 0 emos, and then 1 equals, and this one is holding 1. It doesn't hold multiple the same, it just holds 1 emos. So here we're going to put sum, because I copy pasted it. Sorry. Cool, let's try that again. Alright, so pair keys. 0 holds 0 sum, 0 emos, 1 holds 1 sum, 1 emos. That's neat, so we can store multiple values at one key. And then in our value keys, we have 1 sum is held at 1, 0 sum is held at 0, 0 emos is held at 0, and 1 emos is held at 1. Awesome. But what else can we do with this? Can we say dot get keys of get and let's say 0 sum. Alright, so it's being held at 0. What if we change this to 0? Alright, so it tells us it's being held at 0 and 1. Alright, and let's see what this is showing altogether. Alright, so 0 sum is held at 0 and 0 sum is held at 1. That is really cool. Now, let's put 1 there. So we have 3 ones. Alright, so we're holding 3 values at 1, right here. And then 2 values at, or 1 value at 0. Okay. And then our value keys show that 0 sum is being held at 0 and 1, 0 emos is being held at 1, and 1 emos is being held at 1. And that's pretty good. And we can get the keys for them, for the strings. And that's very, like, you can use this for a lot of things and easily cut down on CPU costs. Instead of looping for entities, you can give them all IDs, put them in their respective hash maps, or pair or set maps, and then go further and keep on making hash maps, or whatever maps you want to use. Just keep making them, so that, say, one map is for specific IDs, position, and other maps for specific IDs, properties, and another one's for maybe their HP, game conditions, all these things, and then another one's for their current AI. And then you just say, okay, let me get this ID, and then put it through those maps, and then act on it. You don't have to loop through anything. You can make more specific loops. You can say, okay, I want these 5 guys to loop and adjust their position. Instead of saying, I want to loop through every single one of my game objects, my tiles, and my entities. That would make no sense. You can cut down on CPU this way. You can also say this entity is being affected by this effect. This one's also being affected by this effect. And then say, what entities are affected by this effect? And then it would spit back the IDs of those entities. That's what I'm referring to. So, yeah. Now, we can see the multiples. Now let's try something else. Let's say set int to string dot remove, every value of 0 sum. And so we have 0 sum at 0 and 0 sum at 1. Will it be in the map when we print it out? And no, it's not there at all. Okay. That's cool. Let's just do that, so that we both have even number. Alright, so 0 sum is not in there, and it gets removed from everything. And that's what we're looking for. So, yeah. In fact, if we look for it, it should say, oh, it's not there. And no, it isn't. And then here we can say contains key, or oh, that's cool. I don't have a contains value. Contains alright, so that's false, because we removed it. Now if we say, take that back, and then start, it's in there. And that's pretty much it. That's how you use HashMaps very intricately, and this is my rendition of them. I'm just using HashMaps to hold my PairMaps and SetPairMaps, and I'll show what that looks like. Here we have our first level of it, and it holds a back map and value keys. The way HashMap works is it holds a key, and then it holds a value, and this value is a pair, and it's very specific. I'm not going to get into it, but just imagine this being one object. And then here in this HashMap, we do the opposite. We hold a key as the value, and then that holds the key that it was set at in the back map. So it's reversed. That way we can say, okay, put the value here in this map at this key. But at this value, put the keys that have this value in this map. So it's very easy to look up. That's what I've been doing. That's how I'm able to list what keys are attached to what value and what keys are attached on this value. So also I have the general abstract things and everything a map, abstract map should have. It's basically a hash map, but it's very, very utility. I don't know how to explain it. But anyway. So that's how that works. And then the toString method, it says all this stuff and then get value keys to string, everything like that. Awesome. So let's go to our SetPairMap, or our PairMap first. And we have put in the map and remove value from key. However, these aren't used. You don't use these directly. These are used within the AMAP. All the AMAP says that you're allowed to use says public v put, and then get pair, and then remove key, remove value, all this stuff, except these abstract things here are being used inside put. So put in the map, KV, that's this. We have to define this right here in the next maps we make. And then same thing goes for the other ones. Object get, that right there. This doesn't seem correct though. I guess I had to do it that way. Huh. If we change this to V, nothing happens, so never mind. Alright, the reason this says object is because if it's a set pair map, this is going to be a set and it's not going to be one defined thing, so we have to do object. Alright, and then clear, obviously. So SetPairMap is a bit more intricate. Here we have backmap.getK remove v if we want to remove value, and then if backmap.getK has no value, remove that key. So if the key doesn't have any value set, it kicks it out of the map. And The only problem with this, I believe, is that in the A map, when we do remove value from key, remove value from key. Okay, well, that seems like an issue. Let's try this. Dot remove value from key. Oh, you don't have that. That's weird. A map remove. Okay, so we're doing it right here. Remove value, and then remove value from key kicks in. Alright, so let's try this. Remove value, and then 1, 0, sum. Alright, so 1 should not have 0 sum, but 0 should. And 1 only has one thing. Cool. However, in our value keys, alright, good. And that's what I was looking for. If we take this out, does it change correctly? And it does. Yep. 0 sum is now being held at both positions, whereas I removed that one from here. 1 didn't have it before. Alright, and that's about it for this. Hopefully you like that and are interested by it, and that's what we'll be using in the game engine. That's what I've been working on for before I stopped programming for a little bit. And it was very fun to come up with, very interesting things I did, and it was like my first utility class I ever made for my own collections. And that's I don't know, I don't know if anybody's ever used something like that. I'm pretty sure they have their own way of doing it, but that reverse lookup is so good. For instance, if we have a grid that we want to divide up between entities to figure out, okay, if this entity is nowhere near another entity, we can check that by making a pretend grid, having a grid object storing entity IDs. So you have basically a 2D array of a hash map. And what it would do is you just store all your points as keys, and then you store a set of IDs. So that when you want to say, what is at this quadrant, at this grid index, what is at it, and it will return entities. Okay. So if this key exists, because in order for this grid index to have an entity, it has to be there. If there's no entity in the grid index, then that means there's no key, so you're not checking it at all. So there's no key, you're narrowing down your CPU efficiency, and that's very good. What would happen is all you have to do is spit out all the keys in that grid index for your hash map, and you would get all the positions that have entities. Nothing else. No other indexes would be included. Only indexes with entities at that grid coordinate location, where you have like a 50 by 50 section of the world, and then you have that's at 0, 0. So 50 by 50 units at 0.00, so it would go from 0 to 50 x, and then 0 to 50 y. And then you just go all the way across, so it's 0, 0, 0, 1, 0, 3, etc. If those have entities in them, they will have keys in the map. If they don't have entities, they aren't even processed. You just wouldn't have to make it, because you're going off the position of the entities with offsets that match the pseudo grid. This grid doesn't actually exist, but it's how the keys are stored. So you just get all the keys of this pseudo grid, and boom, all you have are entities that are filling up spaces, but not an actual grid. and that's all you need. So that all you have to do to check between entities is get the grid coordinate, and then check all the entities inside that. So you don't have to check entities in one quadrant that don't go anywhere near another quadrant, and then check between themselves. That's all you have to do. And that efficiency is very direct. I call it direct efficiency because you can't do anything more efficient than going straight to the point. And so I'll get into that in probably the next video or soon in this tutorial, because that's probably the next step, is making entities and then figuring out how to do collision. It's right there with collision. So I'll see you guys in the next video.